Alright, so yesterday we talked about electron configuration. So I'm going to go back through and I'm going to write the electron configuration for krypton, and then I'm going to show you how to put it into what's called an orbital diagram. So krypton, we would start at, we would do just like we did yesterday, we would do 1s2. Let me get a different marker, this one's not working. So we write the level once we fill it. We would do 2s2, 2p6. Okay. After we fill the 2 p's, we go down to the 3 s's. So 3s2, we have to go over across to the 3 p's. We're going to fill up all 6 of those. Remember, we have to fill the entire floor before we go to the next floor. So the third energy level has to be completely filled until we can go to the fourth energy level. So now that the 3 p's are filled, we go to 4s2. Here's where it gets a little bit tricky, but not too bad. So remember I told you yesterday that the D block, the transition metals, move in an energy level because you can only have 8 valence electrons. Well, if you go across the entire D block, you have 10 valence electrons, or 10 electrons available, should I say. So they have to move up. So now we go 3d10, and then we're going to end at 4p6. So what an orbital diagram is essentially taking these numbers and drawing arrows to represent, electron spin and how the electrons actually fill the orbitals up. So there's 3 rules that we need to pay attention to. There is 2 electrons per orbital, that they spin in opposite directions, and that you have to fill the up direction before you can add any down direction arrows. Now on this one it's not going to make a lot of sense, but the next example I'll give you we'll see what it actually looks like when I say that you have to fill the up direction before you fill the down direction. So this little dash that I'm making represents the 1s energy level. So 1s energy level, I'll look up here, it has 2 electrons available. So I would draw an up arrow and a down arrow. I would do the same thing for a 2s. I would draw an up arrow and a down arrow. They're spinning in opposite directions. I have 2 electrons per energy level. So then I do the same thing for the p's, but since p has 6 and you can only have 2 per orbital, you take that 6, you divide it by 2, so that gives you 3 orbitals that you have to fill. So I've got 6, so I would do up and down, up, down, up, and down. And I would write 2p underneath it, 3s, up, down, 3p, do the same thing that we did for 2p. It's going to be up, down, up, down, down, 3p, 4s, up and down. Now 10 for our D, so we have to have 5 orbitals instead of 3 like we did at P. So 1, 2, 3, 4, 5. We write 3D underneath it. All of them are going to be filled. And then we would do 1, 2, 3 to represent our 4P. And again, all of them are going to be filled. So that would be the orbital diagram for krypton. Okay, now let's do another one for, let's do germanium, GE. Okay, so let's write the electron configuration first. But we're going to do it with the noble gas configuration. So we're going to take the shortcut. So what we would do is we would do brackets. We would find the noble gas before germanium, which would be argon. So we'd write AR in brackets. And then we would just continue as normal. So then we would go 4s2, 3d10, 4p. We would stop. We would count our boxes in and the p's, and we would do 4p2. So now we're going to take this and we're going to do it as an orbital diagram. So now we're going to put some arrows to these letters and numbers. So we draw blank to represent our 4s energy level. We go up, we go down. We do the same thing for our 10. So we have 5 because we have 10 electrons that we have to fill in. So we go up first, and then we would add our downs. Yes, my arrows are messy. That's okay. And so this is where I said you have to fill the up direction first. Since we're at a P, P has 6 available, so we have to account for all 6 electrons. So we have to draw 3 orbitals. we would write 4p underneath it. Since we only have 2 electrons available, we simply have 2 up arrows. Hopefully that makes sense. If we had a 4p3, we would do the same thing. We would have 3 up arrows. If we had a 4p4, same thing, but now we would have 1 up arrow, 3 up arrows, and then 1 down. Same thing for 5, we would have 2 down, 6, they would all be full. So hopefully this just gives you a brief explanation on how to do orbital diagrams. We're going to be working with them a lot this unit. So remember, the 3 things you need to know is each orbital can hold up to 2 electrons, that the electrons spin in an opposite direction, and that you have to fill the up direction before you can add any down directions. Now in this first example I did, I just filled them up because I knew I was going to fill them up. Okay, this is where you have to pay attention. So right there, have to fill the ups before you add any downs. And that's it for the day. If you need anything, feel free to let me know.